In this video here, we're going to take a look at first order differential equations. So before we work our way through this chapter on methods in differential equations, let's just quickly recap what we know about solving differential equations from A-Level Maths. So as we worked our way through integration in A-Level Maths, we saw how we could solve first order differential equations by separating the variables. So if we can write a first order differential equation in this form here then, so dy by dx is equal to f of x g of y, then we can solve it by writing it as follows. So the integral of 1 over g of y dy is equal to the integral of f of x dx. However, we may not always be able to express our differential equation in this given form here above, and in that case then we will need a new method to solve our differential equations. So the method that we're going to use here to solve these differential equations is called the integrating factor method. So if we have a differential equation of this given form here, then we can solve it by using the integrating factor method, where the integrating factor is e to the power of the integral of p of x with respect to x. And you may find it useful to note the following here to solve a differential equation in this given form here. So you can think of this almost as a checklist for solving differential equations given in this form here. So the first thing that we do here is we get the differential equation into this form here, okay? Sometimes it might already be in this form, sometimes you might have to do a little bit of manipulation to get it into this required form here. We then find the integrating factor, where the integrating factor is, as we've already mentioned here, right, e to the power of the integral of p of x with respect to x. We then multiply both sides of the differential equation by the integrating factor. We then integrate both sides of the equation with respect to x. And then finally here, we rearrange the solution to be able to form y equals f of x. So on paper, that all sounds quite nice and straightforward, but as always with A-Level Further Maths, nothing is straightforward, right? So in terms of an introduction here to first order differential equations, we don't need too much more, right? All we're looking at here is this as a new method for solving differential equations here, okay, or first order differential equations. So that concludes our introduction here. Let's just have a go then at one practice question here for first order differential equations. So let's just have a go then at this one practice question here for first order differential equations. So starting off with part A then, which asks us to find the general solution to this given differential equation here. Now clearly we want to use an integrating factor here to find the general solution to this given differential equation, but in its current form we do have a slight problem. So what we require here is dy by dx plus p of x times by y is equal to q of x here. Now clearly we can see straight away then that for the given differential equation here, this is not of the correct form. So what that means then is we need to do a little bit of rearranging here to the given differential equation to get it into the correct form. So for part A then, we were given dy by dx is equal to e to the x plus 3y. Okay. Now hopefully you can spot then that to get it into this form here, all we need to do is subtract 3y off both sides. So nice and straightforward then. We get dy by dx here minus 3y is equal to e to the x here. Okay. So in this form here then, it now satisfies this condition. So what that means then is we can now use an integrating factor method. So to begin with here then, let's actually just find the integrating factor itself. So the integrating factor, which I'm going to abbreviate to I dot f here, this is given as follows. So it's e to the power of the integral of p of x with respect to x here. Okay. Now, just in case you can't spot what p of x will be here, so p of x here is simply minus 3. Okay, so p of x is equal to minus 3. So in that case then, our integrating factor here is e to the power then of the integral of p of x with respect to x. That's minus 3 dx here, which if we evaluate, nice and straightforward, that's simply e to the power of minus 3x. Okay, so this here then is our integrating factor. So now for the next step here, we just multiply through by the integrating factor itself. So what I'm going to get here is dy by dx times by e to the minus 3x. We get e to the minus 3x times by dy by dx here. We then have minus 3y times by e to the minus 3x. So altogether then, we get minus 3 e to the minus 3x times by y. And that is equal to e to the x times by e to the minus 3x. So e to the x times by e to the minus 3x. Okay. So now for the next step here, this can be a little bit tricky to spot what's actually happening. But on the left-hand side here, what we have is the reverse product rule. So in this case here, my left-hand side is just the same as d by dx of my integrating factor, so that's e to the minus 3x. So e to the minus 3x here times by y. Okay. And that is equal to, so now on the right-hand side here, then just simplify this product. So nice and straightforward. That is equal to e to the minus 2x here. Okay. So now for the next step here, we just integrate both sides. So if we integrate the left-hand side, I simply get e to the minus 3x times by y. So e to the minus 3x times by y here on the left-hand side. And now on the right-hand side, then let's just integrate e to the minus 2x here. So we integrate e to the minus 2x here with respect to x, of course. So now if we actually evaluate this integral here, obviously the left-hand side is just the same. So e to the minus 3x times by y here. And that is equal to, we get minus a half e to the minus 2x here. Okay. Now, we don't have limits on the integral, so we do need here the constant of integration. So plus c there. Okay, so don't forget the constant of integration. And then we're pretty much done at this point, right? We just want y here. So y equals would give us the general solution to this given differential equation here. In that case, then all we need to do here is divide through by e to the minus 3x. So y is equal to, so I get minus a half e to the minus 2x divided by e to the minus 3x. So just simplifying the powers here then, we get minus a half e to the x. And we do also divide the constant of integration here by e to the minus 3x. So dividing by e to the minus 3x here, that is just the same as timesing through by e to the 3x. So what we get here then is plus c times by e to the 3x. Okay. So this here then, this is the solution to part A. This is the general solution to this given differential equation here. So let's just make a note of that here then. So this here is the general solution. So that's our general solution there, giving us a solution to part A. So to finish with here, then let's just have a go at part B, where we want to find the particular solution which satisfies the condition that y equals 3/2 when x equals 0. So before we do anything else here, let me just quickly clear, or not clear the screen, but let me just kind of box off my answer to part A, just to make things a little bit easier to see. Okay. So apologies, by the way, I do appreciate that my layout isn't the neatest, but hopefully you can follow along. And let me do it in a different color, just to make it a little bit clearer. So for part B then, we'll do that in dark red here. Okay. So for part B then, what we want to do here is find the particular solution given this boundary condition here. So we know then that y equals 3/2 when x equals 0. So let's make a note of that here then. So x equals 0 and y is equal to 3/2. So to find the particular solution which satisfies this condition here, all we need to do is substitute this value of x and this value of y into our general solution, solve for c, and then just rewrite the general solution with that value of c that we've just obtained. Okay. So in that case, then what we get here is 3/2 is equal to minus a half times by e to the 0. So minus a half times e to the 0. We then have c times e to the power of 3 times 0. So that's just e to the 0 again. We get plus c e to the 0, like so. Now don't forget then that anything to the power of 0 here is 1. Let me do it underneath here. So I get 3/2 is equal to minus a half times 1. So that's just minus a half. We then have c times 1, so that's just c there, like so. Add a half here to both sides then, so I get 3 over 2 plus 1 over 2, so that's 4 over 2, which is just the same as 2. So in that case then, we obtain that c equals 2. And then all we need to do here to finish with is just rewrite the general solution with this value of c. So in that case then, this would give us the particular solution which satisfies this condition. So y is equal to minus a half e to the x plus, so again, don't write c here, write this value of c. Okay, so c equals 2, so I get 2e, so plus 2e to the 3x there. Okay, and there we have it. So this is the solution here then for part B. So this is what you need to obtain for part B. And there we have it. So that's the solution to part B. This here is the solution to part A. And that gives us the solution here then to this one practice question for this video. And that actually brings the end then of this video here on first order differential equations.